Hi everyone. So today we're going to talk about convergent boundaries. So yesterday we talked about transform and divergent boundaries. So converge, diverge, transform. San Andreas. Okay. So but converge is like what you would see is coming together. Okay. Diverge means that they're separating, and transform is that they're in between, and so they're transforming between the two. Okay, so just to go ahead and get you started. So this one's going to be, I went ahead and separated this one from the others because it does take a little bit more time because we have three different types. All right, so what are convergent boundaries? At the convergent boundaries, plates move towards each other and collide. Okay, the subduction zone. So this is actually a very key word, is the subduction zone. And I do not see my highlighter, or I would get it for you. Okay. I can actually just make a scribble. The subduction, sub is like submarine. So submarines are down below. Okay. Superman high. Subscript, superscript. Okay. All right. So a subduction zone is where one plate is more dense than the other. The denser plate sinks beneath the less dense plate, and the process is called subduction. Subduction comes from the Latin root subductus, which means removal. All right, remember, and just a key thing, because density is such an important part on this, is that when something's more dense, it has more matter in a smaller amount of space. And so it's going to be pulled down by gravity, and that's why it sinks. So again, we're going past the big boy and big girl words of sink and flow. You'll use more dense or less dense. So if I have a sponge, it tends to be more dense than it's going to be less dense than water, so it floats on top. We did a quick lab where we had alcohol and wax. So wax was less dense than water, so it went on the top because there was more gravity pulling the water down. Okay, but water and alcohol is less dense, so it was on top. However, wax is more dense than alcohol, so it could go um, water, wax, and then alcohol. Okay, most alcohols are less dense than, as a reminder, there's a million types of alcohol. Okay, now oil and water. Oil sets on top of water, but they don't combine due to another property of water and oil. But water is more dense than oil, so that's why it separates. It's called the separation coil. Okay, so the bigger the number, the substance is going to be on the bottom. Okay, density's relative thing is water, just pure water, and it's 1 gram per centimeter cubed. Gram is mass, centimeter cube is volume. Okay, all right. So density is also another key thing in all of this. Okay, and that's another key word. Okay, will it sink? Will it sink? Okay. So on this here, we have arrows, and then we have squigglies, and then we have Australia. Okay, so, and we're still in topic 4. Okay, pause it. Oh, we have 2 squigglies here, right? And if I were to go back, I did talk about 2 different crusts on the Earth's layer. We talked about the oceanic, and we talked about the continental. So these squigglies are actually representing the oceanic crust, and the Australia is the continental crust. Okay, this is not the water, it's just representing the oceanic crust within those plates, and there is a major difference. Going back to what we were talking about earlier, Iceland has black sands because it's volcanic. There's another few places in the world that do have black sands, one of them being Hawaii because it's a volcanic island. Iceland is the island of fire of ice. It's up on the 62nd parallel, but it's got some really cool features because it's a volcanic area. We are not a volcanic area here in Kansas. All right. So again, these two are going to battle it out. Who's gonna win? Will it sink? Will it sink? Will it sink? Okay. Oceanic and continental plates collide. The denser oceanic plate subducts under the continent. This creates a deep ocean trench of line of volcanoes that form above the subducting plate of the continent. And so I'm going to go ahead and show you a demonstration on this. So if I'm going to reset. Now you guys, I would love to have this. I'm going to put young continental coast in there. I'm going to make my density so you guys can see, oh, that's pretty high. And I'm going to show all seawater, show labels. Now the seawater is not very important. Now the oceanic crust, if you notice, is actually pretty dense. Okay. Now I am going to go ahead and show. Keep going. Keep going. So 13, 14, 15, 20 million years. And what do we have coming up? Oh, it did stop after 50 million years. We've got a thing called a volcanic arc that comes up. I'm going to reset. I'm going to rewind. And I'm going to go again. Oh, there's something strewing over 20 million years. So this takes some time, guys. This isn't quick and doesn't quickly go away. Okay. If you notice, the temperature is pretty high here compared to the rest of the arc. Okay. Pause. Okay, so I'm going to just show you guys real quick with the continental crust versus the old one. We did young, but what you'll see is that you get the same effect. We will talk about old versus new. You're still going to get a volcanic arc, just to let you know. Okay, and we get the same effect, and you see that it's moving. The bottom part here is not moving as much. Okay. So what happens when I have oceanic versus oceanic and they're coming together? Well, that is another battle, okay? And it depends on when two oceanic plates collide, the older and denser plate subducts, creating a deep ocean trench at the line of the volcano. It's called an island arc. This is how the island arc of Japan was formed, okay? So once again, I'm going to try to show, or not once again, but so Japan, if you did not know, I have talked about it with my chemistry class with Fukushima, which is a island. I'll show you the island. Now, this area is full of countries with islands, islands, islands. Same way that the Philippines is, because this is on, so here's the island of Japan. Indonesia has 20 to 30,000 islands. Okay, same way with the Philippines, which is in the same area. There's Japan once again, and it's basically a whole bunch of island arcs. Okay, so I'm going to spend a little bit of time. I'm going to reset this. So we have young versus young island arcs, and they're separating. Okay, so this is more of a divergent because they're both very young. Now, if I had a old oceanic crust and a young oceanic crust, who's gonna win? The temperatures are about the same. The densities, this is, oh, I have to show labels. So this is the young densities here. The density of the old oceanic crust is, that's the water, is a little bit higher. Okay, so I'm going to pull and I'm going to say the old oceanic crust is going to win. And it creates a island arc that comes out, and it can actually make terrestrial landforms, if you see here. And after millions of years of doing this, we can form things kind of like Hawaii, a little bit different. Those are hot spots. But like island countries like Indonesia, that we'll come back to. It's got Krakatoa on it. The Philippines, which has got the big island of Luzon, and that's got a Pinatubo, which I actually have seen. And I hope you guys get to see a volcano and lava for the first time in your life. It's pretty awesome. And then also the island of Japan, okay? All right, which has got Fuji. All right, okay. So the old oceanic crust is more dense than the young, and it's going to subduct underneath. So the last one is continental versus continental. Who's gonna win? Who's gonna win? Let's go see. I've got to reset all. So I've got continental baby, and we've got the densities are about the same. Now that's not in reality. It's not going, no seawater, right? I'm going to have both. You can see it gets hotter. And my temperature is hot down here, but as we go up, they're going to be the same. Well, let's get them together. Boom! And 10 million years. Boom! 10 million years. Boom. Okay, and it made a really V shape here and some weird terrestrial things, but that's after 35 million and it stopped. It causes mountains. Okay, this is, you'll see in that video previously that that oceanic plate is slamming into the Eurasian plate, and we're having the Himalayas, which has the tallest mountain, Mount Everest, and then K2, which there's a debate which one's actually bigger. Kind of the same thing that's happening in the Rockies. All right, so I'm going to let this be here. I might go back and show you guys. I kind of did not take my time on that. Is when two continental plates collide, both plates are equally dense, so the plates slam into each other and the mountains form uplifting rock. This is the world's largest mountains in the Himalayas, which is in Nepal, India, and Tibet. Not really China, but it really is, but that's a political thing. Form. Mount Everest continues to grow taller every day. There's a lot of seismic activity within that area. Okay. Kind of another mountain chain is the Andes, which is in South America, coming from Ecuador to Peru, down to Chile, and on down, which then causes the Amazon, the largest volume river in the world, substantially. Okay, so when we go over that, this would go here, continent versus continent, oceanic versus oceanic, and then oceanic versus continent. Okay, I have a little bit of time here on this video, so I'm going to let you have that so you can see. There's continent versus, oceanic versus oceanic, old versus new. The old subducts. I don't know if it wins or loses, but it's subducting. You got to remember millions of years, not 50, not 40, 50 million, 40 million, and it creates those island arcs. And then we have the convergent of the continentals, and we form mountains. That's a little bit how the Rockies are made too, if you've ever been to Colorado.